Hello and welcome. In this video, we're going to talk about partial derivatives. Alright, so from our knowledge of differentiation, if we have a function, say y equals to 4x cubed plus 3x, to differentiate this, we're differentiating y with respect to x. And we're simply following this rule of multiply the power by the coefficient and subtracting 1 from the power. So here we're going to have 12x squared plus 3. Now what if we have a multivariable function such that z equals to x squared y plus 3xy squared? In order for us to differentiate this, we have to apply partial derivatives. In partial derivatives, we differentiate the function partially with respect to x, and then we differentiate the function again partially with respect to y. So whenever we differentiate with respect to x, we keep y constant. And whenever we differentiate with respect to y, we keep x constant. So when I differentiate the function partially with respect to x, I write it this way. dz dx. This symbol is showing us that I'm differentiating partially. Compared to writing it like this, we write it this way. Alright, so partial z, partial x is equal to, I want to differentiate x squared y. I'm differentiating partially with respect to x, so I'm going to keep y constant. So this becomes 2x, and keep y constant, y. Plus, I want to differentiate 3x y squared. I'm going to differentiate 3x, that will give me 3, and then I'm keeping y constant, so this is y squared, and that is it. Now I'm going to differentiate the function partially with respect to y. So differentiating with respect to y, I'm going to keep x constant. So when I differentiate y, I have 1. And then I'm keeping x constant. So this is x squared. Plus, when I come here, I'm keeping 3x constant. So when I differentiate y squared, I have 2y. So I'm going to have 3x multiplied by 2y. And so my partial derivative is going to be equal to x squared plus 6xy. I'm going to go over it one more time. Differentiating z partially with respect to x, I'm going to keep y constant. So drop y, keep y constant. Differentiate x squared, I have 2x. I'm keeping y constant, so drop y squared. Differentiate 3x, I have 3. Differentiating partially with respect to y, I'm going to keep x constant. Differentiate y, you have 1. So you have x squared. Then keeping x constant again, drop this 3x, then differentiate y squared, I have 2y. So x squared plus 6xy. Now let's look at more examples. Alright, we have a question here. If z equals x cubed plus y cubed minus 2x squared y, find the partial derivative of the function with respect to x and with respect to y. Alright, so when I differentiate my function partially with respect to x, I'm keeping y constant. So differentiating this gives me 3x squared. Y is constant, which means whenever you differentiate a constant, you have 0. Alright? It's just like differentiating 5, differentiating 6. Whenever you get confused at any point in partial derivatives, whatever you make the constant, try replacing it with a value and differentiate it. So when I differentiate this, I have 0. Minus, when I differentiate this, I'm keeping y constant. So I differentiate 2x squared, I'm going to have 4x. I'm keeping y constant. So partial z, partial x gives me 3x squared minus 4xy. Alright? So what is partial z, partial y? You can pause the video and try this. Alright? So to differentiate partially with respect to y, I'm going to keep x constant. So once again, when I differentiate this, you know it's a constant, I'm going to have 0. Plus, when I differentiate y cubed, I'm going to have 3y squared minus, keeping this constant, I'm differentiating partially with respect to y, I'm keeping x constant. So drop the 2x squared, we're keeping it constant. When we differentiate y, we have 1. So this gives us 3y squared minus 2x squared. Very, very simple. Very, very simple. Now let's go to product rule. Product rule for partial derivatives. Okay, we have that if z equals 2x minus y, x plus 3y, differentiate it partially with respect to x and with respect to y. So to differentiate z partially with respect to x, first and foremost, we have to remember our product rule formula. Our product rule formula, let's take this as u, let's take this as v. Alright, so in product rule, we differentiate, we drop u, right, and then we differentiate v prime, plus we drop v, and then we differentiate u prime. As simple as that. So that is exactly what we're going to be doing, but instead we're going to be differentiating partially. So to differentiate partially with respect to x, we drop u, this is 2x minus y. And then we differentiate v partially with respect to x. In differentiating v partially with respect to x, we keep y constant. Okay, so when we differentiate x, it becomes 1 plus y is constant, this is a constant. When you differentiate a constant, you have 0. Alright? Plus, you drop v. V is x plus 3y. Then you differentiate u. In differentiating u, when differentiating partially with respect to x, we keep y constant. So when you differentiate 2x, you have 2 minus, when you differentiate y, you have 0. Because when you differentiate a constant, you have 0. So this gives us 1 multiplied by 2x minus y plus 2 x plus 3y multiplied by 2. Okay, so we can still simplify. We're going to have 2x minus y plus 2x plus 6y. And this gives us 4x plus 5y. And that is the partial derivative with respect to x. Now, let's solve for y. So, differentiating partially with respect to y, we follow the same rules. Drop u, 2x minus y. Now, differentiate v partially with respect to y. So, when you do that, you keep x constant. So, when we differentiate x, which is a constant, we have 0. And when we differentiate 3y, we have 3. Plus, drop v. We're going to have x plus 3y. Differentiate u partially with respect to y. So you keep x constant. So again, 2x becomes 0 and differentiating y becomes 1. So here we're going to have 2x minus y multiplied by 3 plus x plus 3y multiplied by minus 1. So this becomes 6x minus 3y minus x minus 3y. And this becomes 5x minus 6y. And this is the correct answer. I've come to the end of this video. In the next video, we're going to look at quotient rule for partial derivatives. Thank you very much for watching. Don't forget to like, share, subscribe, and drop a comment.